From the intricate workings of a wristwatch, where each tiny gear plays a crucial role in keeping time precise and accurate, to the massive gears propelling colossal ships across vast oceans, ensuring the smooth and powerful movement of these maritime giants, these toothed wonders have captivated human ingenuity for millennia. They are the driving force of countless machines, from the simplest to the most complex. Gears, in their essence, embody the very principles of the cosmos: predictable motion, transfer of energy, and the dance between circular and linear forces. They are a testament to the harmony and order that can be found in both the mechanical and natural worlds. But have you ever paused to ponder the intricate ballet of a less conventional gear pair, the cycloidal eccentric duo? These gears challenge our traditional understanding and open up new possibilities. Imagine, if you will, a universe where gears transcend their traditional form, where innovation meets elegance, where smooth, almost planetary motions replace the abrupt starts and stops of conventional gearing. This seamless motion is not just a mechanical marvel, but a glimpse into the future of engineering. Welcome to the realm of cycloidal eccentric gears, where the boundaries of traditional mechanics are pushed and new horizons are explored. Here, the future of motion is being redefined. Unlike their commonplace counterparts with their familiar teeth and predictable rotations, traditional gears have been the backbone of machinery for centuries. Cycloidal eccentric gears, however, operate with a unique elegance that sets them apart from the ordinary. Picture a gear that doesn't just rotate but also glides, tracing a path reminiscent of celestial bodies in their orbits, creating a mesmerizing dance of mechanical precision. This is the essence of cycloidal motion, a harmonious blend of rotation and translation. Now, introduce an eccentric element, a subtle offset in the rotation axis that adds a layer of complexity and sophistication to the movement. This eccentricity, combined with the cycloidal profile, allows for remarkably smooth and precise power transmission even in the most demanding applications, ensuring efficiency and reliability in modern engineering marvels. Visualize for a moment a child's spirograph. The intricate patterns emerge from a small gear rotating within a larger ring. Cycloidal gears operate on a similar principle. The cycloidal gear, with its unique profile, engages with a fixed ring gear, but here's the twist: it doesn't simply mesh at the teeth. Instead, the point of contact between the gears glides along the cycloidal curve, resulting in a nearly frictionless rolling motion. This smooth, continuous contact minimizes vibration and wear, characteristics highly desirable in precision machinery. Precision in motion. Advantages in modern machinery. The world of high-precision machinery demands components that operate with exceptional accuracy and minimal backlash. This is crucial in industries where even the smallest error can lead to significant issues, whether in manufacturing, medical fields, or advanced robotics. Here's where cycloidal eccentric gears truly shine. These gears are designed to handle high loads and provide smooth, reliable motion, making them indispensable in various high-precision applications. Cycloidal eccentric gears are often referred to as a cycloidal drive or cycloidal speed reducer. Their ability to transmit motion with incredible precision makes them ideal for applications ranging from robotics to printing presses. In robotics, for instance, the accuracy of these gears ensures that robotic arms can perform complex tasks with ease and reliability. Consider, for example, the delicate movements required in surgical robots. These machines must translate the surgeon's hand movements into precise actions, often within the tight confines of the human body. Cycloidal eccentric gears ensure smooth, controlled motion, translating the surgeon's hand movements into precise actions within the confines of the human body. This precision is critical for the success of minimally invasive surgeries, where accuracy can significantly impact patient outcomes. Similarly, in high-speed printing presses, these gears maintain perfect alignment, guaranteeing crisp, clear images even at breakneck production speeds. The reliability and precision of cycloidal gears ensure that every print is of the highest quality, meeting the demanding standards of the printing industry. The cycloidal eccentric gear allows for smooth, precise motion due to several key elements. Their eccentric shaft creates a unique motion that allows the cycloidal disc to move in a very controlled manner. This controlled movement is crucial for achieving precise positioning. The cycloidal disc, with its lobes or teeth, meshes precisely with the pins or rollers on the stationary ring gear. This ensures that the motion is smoothly transferred without any significant backlash. The continuous engagement of multiple lobes with the pins or rollers distributes the load evenly, enhancing precision and reducing wear. One of the main advantages of cycloidal drives is their extremely low backlash. The design ensures that the input motion is directly and accurately transmitted to the output, which is essential for applications requiring high precision, such as robotics or CNC machines. The use of rolling elements, such as bearings, in the design reduces friction and improves efficiency. This smooth operation contributes to the overall precision of the drive. The ability to handle high-torque loads without deformation ensures that the drive maintains its precision even under varying load conditions. This robustness is particularly important in industrial applications where consistent performance is critical. The compact nature of cycloidal drives allows them to be integrated into systems where space is at a premium without sacrificing precision. This makes them ideal for applications in robotics and automation where precise control in a compact form factor is necessary. The cycloidal motion of the disc provides a harmonic, smooth transfer of power from the input to the output. This harmonic motion reduces vibrations and enhances the accuracy of the drive. The future of finesse, potential, and possibilities. As technology continues its relentless march towards miniaturization and increased efficiency, cycloidal eccentric gears stand poised to play an even more pivotal role. Their compact size, coupled with their exceptional performance characteristics, makes them ideal for applications in micro-robotics, aerospace, and beyond. Imagine, for instance, tiny robots navigating the human bloodstream, delivering targeted drug therapies or performing delicate surgical procedures. Cycloidal eccentric gears, with their smooth, precise movements, could be the key to unlocking such groundbreaking medical advancements. A universe of gears, concluding thoughts. Just as the cosmos relies on the interplay of celestial bodies, the world of engineering relies on the elegant dance of gears. Cycloidal eccentric gears, with their unique blend of smooth motion and precise control, represent a leap forward in our quest to harness mechanical motion. As we continue to push the boundaries of what's possible, these intricate gears will undoubtedly play a critical role in shaping the future of technology. Thank you for watching. If you liked this video, don't forget to click the like button and subscribe to us for more machine theory topics.